All right, let's take a look at some sample questions from the oblique triangles test. All right, we're just going to do a few of these just to give you kind of a feel for how things work. Let's do problem number 2. And this is little a is 12, little c is 37, and measure angle A is 12 degrees. Okay. All right, our standard setup here, since we have A as being the given side with an opposite angle, we're going to put that in front. So A goes here. The side that does not have an opposite angle is going to go here. And then the measure of the angle goes with sine. So sine A goes here. Okay. And remember, this is, we're testing SSA. All right, the condition of SSA, which is a non-included angle. Little a is 12, so that goes there. And then little c is 37, and the measure of angle A is 12. So this is what that test looks like, the first part of that test. There are two conditions for it. We'll take a look at those in just a second. And we're going to do 37 times sine 12. Making sure our mode is in degrees, and it is. And that gives me 7.69 for this piece. 7.69. Comparing that to 12. 12 is greater than. There are two conditions in which A is greater than B sine A, or C sine A for us. And one of those is in the case in which we have to compare both of them. We have to compare A to B to see which of these two conditions exist. So let's do that now. Let's compare A to C instead of A to B, since C is our side without an opposite angle. So 12 and 37, and 12 is definitely less than 37. So when we can look at our conditions for comparison, we can see that A is greater than B sine A and A is less than B. For us, B is C. Then two triangles exist. All right, so we're just going to say two triangles exist. That's our answer for number 2. Okay, let's go to another sample. We're going to take a look at number 4. In number 4, we have area. So we're solving for the area of a triangle. For this particular problem, because of the information that's given, our formula will be 1/2 AB times sine C. And we'll talk about that in just a second. So let's look at the information that's given. For number 4, we're given that little a is 18 inches. Measure angle B is 42 degrees. And measure angle C is 73 degrees. Okay. Now, what I'm looking for this area formula is side angle side. And what I have is angle side angle. I draw this thing just as a standard triangle. Doesn't really matter exactly how we do that. We'll let this be A, B, and C. All right, and then we know that measure angle C is 73. Okay, measure angle B is 42. And little a is, which is opposite angle A, is 18. Okay, we need side angle side to use this formula, so we need to solve for either this side or this side. That process includes the following. Adding these two together and subtracting from 180 degrees gives me 65 degrees for this piece. All right, so now I can set up my law of sines to solve for either of these two pieces, and I'm going to solve for little b, okay, which is this side. So we're going to set this up as a side and an angle that we know opposite each other, sine 65 over 18. is equal to, and in this case we're looking for little b, so we're going to do sine 42 over little b. We're going to cross multiply those. B sine 65 equals 18 sine 42. And we're going to divide by sine 65 on both sides. Or just divide by sine 65, however you want to do that. And little b equals, and we'll put that in the calculator. So we're going to go to 18 sine 42. Divided by, close your parentheses there so it doesn't mess things up, divided by sine 65. And that gives us 13.289, which we'll keep in the calculator. 13.289 approximately. So we'll now come over here and we'll look at what we know now is that we have, if this is approximately 13.3, we have side angle side. And so we can use this formula now. So 1/2 area equals 1/2. Little a is 18. Little b is 13.289, which we'll try to remember to put in the calculator that way. And then times sine of c, which is 73 degrees. Okay. So we'll now go to the calculator. And remember, this is already in there. So we're going to do 1/2 times 18 times, I'm going to jump up here and grab that value. Okay, and then times sine 73. 73, plot, remember my mode is already in degrees, so I'm in good shape here. So entering gives me 114.379 or 114.4. 14.4, and we're looking at inches, so area is inches squared. Okay. All right, let's do a little right triangle review with problem number 7, and we'll jump right back into the oblique triangles, which are non-right triangles. Okay, so this one is a right triangle with degrees and minutes. We'll review degrees and minutes when we put it in the calculator. Okay, 32 degrees and 19 minutes. This is x. I haven't labeled A, B, and C because I'm going to show you how to do that without A, B, and C. Okay, we're trying to find x. And remember that this is theta. All right, that makes this opposite. And that makes this the hypotenuse, which is 21. We're going to do sine theta for that. Sine theta, 32 degrees and 19 minutes is equal to opposite x over 21. And we're going to multiply by 21 to get that 21 out of the denominator. So 21 sine 32 degrees and 19 minutes is equal to x. Let's go to the calculator and solve that one. See if we can't manipulate our calculator here to make everything work. And I'll just move it up and show it as we need to. 21, and then we're going to go to sine 32, and remember our process here is we go to second apse, choose number 1. Okay, then we go back to 19, same thing, second apse, choose number 2. And there's our degrees and minutes. If we want seconds, then we choose the alpha button and we go to plus. Okay, alpha plus is seconds, all right? And we hit enter, and since our mode is still in degrees, 11.2 is our answer. Okay. All right, number 10 is the two possible triangles. We'll go through the whole thing with that one. We got measure angle A is 58 degrees. We've got little a is 11.4 and little b is 12.8. All right, I like to draw the triangle the same way every single time. Notice we have side-side angle because we have one side with its opposite angle only, so this is side-side angle. And we're going to have to do our testing here first to see how many triangles there are, but I'm just going to go ahead and tell you there's 2 possible triangles. Let's just go ahead and set it up and draw it. I like to draw it exactly the same way every single time. All right, we make a right triangle. We make 2 line segments for the opposite side. Okay. And that way, every single time we know exactly where the pieces go. I'm going to put measure angle A here. So this is 58 degrees. I'm going to put the opposite side to that one, little a, in this position, 11.4. That'll be the same here. This is also A equals 11.4. And then the other piece, the other side that doesn't have an opposite angle is going to go right here. So little b is 12.8. Okay. So we tested this. It is 2 triangles. We're going to go ahead and set up and solve for those 2 triangles. So one of my triangles is the acute triangle. Okay, and that's going to give me A. We're going to put B here, and B prime there, and then C here. Okay, there's 2 different C's. We'll talk about what those are. So this is B, and this is C. Okay. And what we know so far in this first triangle is that this is 58, and that little a is 11.4. Okay. And we know that little b, of course, since it's the same in both triangles, is 12.8. We'll put that right here, 12.8. And now we're going to draw our obtuse triangle. And we'll talk about where those pieces are and how they work. So here comes my obtuse triangle. And again, we're going to label A, and then we'll make this B prime and C prime, since you can see that those are different angles from these 2. All right. So this comes from acute, whole thing. That's this one, and obtuse is this piece right here. And we're going to fill in like we did before. This one is 58. Okay. This one is little a, 11.4, and this one is little b, 12.8. Okay. And what we're going to do is we're going to solve for angle B using our law of sines. All right. If it's acute, we're going to put it here. If it's obtuse, we're going to put it here. And we'll subtract 180 to get the other piece. All right, so let's use this information to set up law of sines. Okay, we'll do that right here. So we're going to do sine big A, which is 58, over little a, 11.4, is equal to sine of B. We're going to do big B, since we don't know that, and we're going to put little b right here, 12.8. Okay. We're going to cross multiply that and finish solving it. And I'm just going to write it off to the side here and then put it in the calculator for you. So you get 11.4 sine B is equal to 12.8 sine 58. Make sure that's showing up on the screen. Yep. And we're going to divide by 11.4 to get sine B is equal to 12.8 sine 58, all divided by 11.4. Okay, we'll go to our calculator, throw that in there. So we're going to do 12.8 sine 58, always checking to make sure the mode's in degrees. All right, and then close parentheses divided by, oops. Oh, let's see, I think I hit the wrong thing. Try again. 12.8 sine 58 divided by 11.4. Wasted a little time there, but that's okay. Okay, so that gives me sine B. Sine B equals 0.9521. And we'll go ahead and just keep that in the calculator when we do our find the angle measure second sine. And we're just going to go and grab that, plop it in there, hit enter, 72.2. So measure angle B approximately 72.2. All right, well, that's acute, so it's going to go in this one right here. So 72.2 approximately. And I'm going to subtract that from 180 to get the measure of angle B prime. Okay, so we're going to do 180 minus this piece, plop, and 107.8-ish. So that's 107.8-ish for that one. Okay. And then, of course, if I know two angles, I can find the third angle. So I'm going to do that for the acute triangle, do that for the obtuse triangle. And I'm just going to use law of sines in each one to find the missing side lengths. Okay, so let's do the last one here. We're going to do 180 minus 58 plus 72.2-ish. And that gives me 49.8 for C. So 49.8. And we'll do the same thing in the obtuse triangle. We're going to add these two and subtract from 180. So 180 minus 58 plus, and then my 107, I'll go grab it here, plop. And that gives me 14.2-ish. So that one's going to be 14.2 degrees, okay? I'll solve for the missing piece here, which is little c, by using law of sines, and I like to use pieces that I know already, usually from the original problem. So if I'm looking for little c, I'm obviously going to do sine of angle C, 49.8, which I can use the calculator value for, divided by C is equal to, and then I'm going to use something I'm familiar with, and that's A, so we're going to do sine 58 divided by 11.4, and cross multiply. So C sine 58 is equal to 11.4 sine 49.8. I'll try to remember to put that in the calculator when I do it. And dividing by sine 58 is going to give me the answer for little c on the left-hand side, 11.4 sine 49.8 divided by sine 58. Let's go. All right, picking back up with this calculation for c, let's go to 11.4 times sine of 49.8, which we rounded earlier, but we could put that exact value in there if we needed to, and then divided by sine of 58. And that gives us 10.3-ish. So little c, 10.3, put that right there. Okay. And over here, we'll do the same kind of thing we just did before to find little c prime. We're going to set it up exactly the same way, except with different numbers here. So we know that we're looking for c. We're going to do sine of 14.2, which is c prime, over little c, which we don't know, is equal to, and then we're going to do sine of something we're familiar with, 58 degrees divided by 11.4. There's my law of sines for that one. So we're going to do cross multiply, and we get c sine 58 is equal to 11.4 sine 14.2, and of course divided by sine 58. So 11.4 sine 14.2 divided by sine 58. Go to the calculator, see if we can make that work this time. We're going to do our, just put it here beside it, 11.4 sine 14.2 divided by sine 58, and that's 3.3-ish. All right, so little c for the second triangle is little c prime, sorry, I should put little c primes here all the way through, is approximately 3.3. Okay, and there is our problem number 10 worked out completely.